Okay, so for part two of this review, we're going to be talking about operations with polynomials. So adding, subtracting, multiplying, and what's new is dividing polynomials. So when you are first here multiplying is pretty straightforward. It's either your multiple distribution or your FOIL method or the box method, whichever one you are most comfortable with. So you have FOIL, which is just the shorthand for multiple distribution, or you can do the box method. So if you choose to do the box method, it's if you're a visual learner, it helps you keep it more organized. So you have your 2x and your positive 3, your x and your negative 4. And that's going to give you your 2x squared, your 3x, your negative 8x, and your negative 12. You're going to combine like terms. So after combining my like terms, I'm going to be left with 2x squared minus 5x minus 12. Okay, dividing is a little different. Dividing, we have what's called synthetic division. So in elementary school, you guys learn how to divide with long division, right? This is useful, and the process is going to be used at the bottom. But we're going to talk about synthetic division. Synthetic division is a two-part non-variable division with polynomial. When you use synthetic division, you are essentially dividing out an x, which means that your quotient is going to always be 1 degree less than when you started, okay? Synthetic only works if it's a linear polynomial. So step one is you're going to take your factor, your divisor, and set it equal to 0. So that gives us x equals negative 1. Step two is the setup. You're going to set it up with your x on the outside. And then on the inside are just your coefficients and constants. So my coefficients are 1, 2, and negative 5, and my constant is 2. So we have 1, 2, negative 5, and 2. This is our setup for synthetic. After you set up, now step 3 is we're going to multiply diagonally and then put the answer and then add vertically and repeat until we can't anymore. So we have 1, we're going to bring it down. So negative 1 times 1 gives us negative 1. 2 plus negative 1 gives us 1. Negative 1 times 1 gives us negative 1. Negative 5 plus negative 1 gives us negative 6. Negative 1 times negative 6 gives us positive 6. And 2 plus 6 is 8. Okay. So technically, none of these are the correct answer because we have a remainder. But we're going to just kind of ignore these multiple choices right now. We're going to talk about what it is as happened. So remember when I said that when you're dividing, you're decreasing your degree because you're dividing out an x. So we started off as a third degree. Now it's going to be a second degree. So these are the coefficients of your quadratic, your second degree. So my coefficients are 1, that's going to be my x squared, plus x, 1x minus 6, okay? And then this is my remainder. So when I write this as a quotient, my final quotient would be x squared plus x minus 6. And I have a remainder of 8, okay? When we write a remainder, we're going to write it as a fraction. So your remainder is I have 8 out of what I initially divided, which was x plus 1. So this would be the exact correct answer. The beginning piece is my quotient, and this is my remainder. Okay. All right. So here again, this is adding. When you're adding polynomials, remember we're just combining like terms. So we have 3x squared here and 2x squared here. That's going to make 5x squared. We have negative 4x and positive 3x. That's going to make negative x. We have positive 2, negative 5. That's going to make negative 3. So my answer is 5x squared minus x minus 3. Subtracting. When you're subtracting, you have to remember to distribute the negative. So it says you're going to subtract 2x squared minus 3x plus 4 from 5x squared plus 2x minus 1. So we have 5x squared plus 2x minus 1 minus 2x squared minus 3x plus 4. Okay, after you do that, you're going to distribute. You do. So we get 5x squared plus 2x minus 1 minus 2x squared plus 3x minus 4. And now it just comes down to combining like terms. So we have 5x squared and negative 2x squared, which makes 3x squared. We have 2x and 3x, which makes 5x. And we have negative 1 and negative 4, which makes negative 5. So our answer would be 3x squared plus 5x minus 5, which is A. All right, next up is long division. So long division is an alternative to doing synthetic division. Long division is only really necessary when your divisor is not a linear, but in this case it is a linear, but we're going to use it to go through the process. Not algebra, in elementary school, you did long division and you learned the process. So there's a little simple step process. How I was taught, or honestly, I don't know where this came from, but I was taught at some point, does McDonald's sell burgers? And what this is the process of dividing with long division. First you divide, then you multiply, then you subtract, then you bring down and repeat. Okay? Does McDonald's sell burgers? Okay, so that's what we're going to be doing. So over here, we're going to set up our long division. So we have 2x minus 1 divided into 6x to the third minus 7x squared plus 2x minus 8. Now notice that my polynomial is in numerical order of decreasing power. You need to make sure that every power is present. So if I had been missing a 0, my x term here, I would put a 0x in that place. So you want to make sure everything is present so that the multiplication, the division can work smoothly, okay? So the step 1 is to divide. So we're going to divide the leading terms. So my leading terms are 6x cubed and 2x. So 6x cubed divided by 2x is 3x squared. After we divide, we then are going to multiply. You're multiplying your quotient times your divisor. So 3x squared times 2x is going to give me 6x cubed. 3x squared times negative 1 gives me negative 3x squared. Then you're going to subtract. As we learned before, when you're subtracting, you have to subtract all terms, which just essentially means you're changing their sign. So it's going to cancel out, and you're left with negative 4x squared, okay? And then you're going to repeat. You're going to bring down and do it again until you can't anymore. So we're going to repeat. So now we have negative 4x squared plus 2x. And we're going to divide our leading term again. Our leading term is negative 4x squared divided by 2x. So negative 4x squared divided by 2x is negative 2x. After we divide, we then are going to multiply. So negative 2x times 2x minus 1 gives us negative 4x squared. Negative 2x times negative 1 gives us positive 2x. And then we're going to subtract, which means we're changing our signs because we have to distribute the power, distribute the negative. And we get 2x plus negative 2x, which is 0x. And then we bring down. And we get negative 8. Okay. Did I do that? Okay. And so then we're now left with 0x. You divide, can't divide. Okay. So this one didn't plan out as pretty as I would like it to, guys, to be honest with you. But we end up with another remainder. I really want this to just be 0, but it's not. We have a remainder with the minus 8. And again, I'm not gonna lie, the teacher I got this from none of those are true. So we end up with minus 8 over 2x minus 1 as our quotient. So we have our answer is 3x squared minus 2x minus 8 over 2x minus 1. would be, because that's our remainder, and that's the beginning. So the part is there. -8. The 2x needs to be something different in order to be our friend. I wonder if that's what they meant. Like that should have been a 4x, you know? Looks like it should have. No, it should have been like an 8x. I think it should have been 8x. This should have been an 8. We would have been better off. Okay. We live and we learn. But yes, so that's that part. Now we're moving on to polynomial inequalities. So solving inequalities for when f of x is greater than 0, that's just a fancy way of saying when y values are positive. Or when f of x is less than 0, which is just a fancy way of saying when y values are negative. Okay, you're going to use number lines or test points to find solutions, and we're going to express solutions using interval notation. So up first, we have which interval notation correctly represents the solution to the inequality if the polynomial crosses the x-axis at x equals -1 and x equals 2 and x equals 3. So the thing here is that you have -1, 2. That's not where 2 goes, y'all. This is how you know your teacher is sleepy. I promise I don't remember two. -1, 2, and 3. Okay. So if you have a polynomial that is crossing, you would need a little bit more information of when it's positive and negative. Yeah, this is not a good, this is missing information. Moving on. In solving, which test point method is most efficient? You're going to always show test points. So when you have a line to figure out whether things are positive or negative, your test points are going to be values that are in that on that interval. So on this interval, this is going to negative infinity. So between negative infinity and -1, you can choose any number. I'm going to strongly, your test point should be the smallest possible number. So my test point here would be -2. Anytime my test point can be 0, it's going to be 0. I try to avoid decimals and fractions, but sometimes you can't. So for here, my test point would have to be 2.5. So you only choose test points in each region. And then on this one, this is going to positive infinity. Again, I can choose any number between 3 and positive infinity, but I'm going to choose 4, the smallest, to test and see if it produces a negative or a positive output. Okay. This one's easy. So this one we have x plus 2, x minus 1 squared. So we have x plus 2 times x minus 1 squared, and it wants to know is it less than 0. All right, you can create a test point and measure it, but we're going to talk about using a graph. So let's go look at the graph. If only I pressed the right buttons. So we had, that's how quickly I forgot, x plus 2 and x minus 1 squared. X plus 2 and x minus 1 squared. Okay, and we're looking for when is it less than 0. So looking at this, these values are all greater than 0 because they're above the x-axis. The only time that I'm less than 0 is here and to the left of -2. So my answer would be when x is less than -2. Okay, or an interval notation, that would be from negative infinity to -2. And it's parentheses because it says less than, not equal to. Okay. All right. Next, it says which statement is true about the solution? The solution is all real numbers. The solution is in negative infinity to -1. I think it's missing the equation. So we're going to just say, I can't tell you what's true. There's no equation. I don't know what happened to it. For the inequality, which method would lead to the correct solution? Okay, so what we want to do is, if when possible, we're going to factor the polynomial and find the test points. But this is when it's equal to 0. So there's a lot of things that has to take place. So for the inequality, it needs to be less than, greater than, less than or equal to, greater than or equal to 0. Okay, so that's the first thing we want to make sure. And then after we do that, then we can factor and create a number line with test points, or we can graph and read whether it's above or below the x-axis. Either way, it's perfectly fine. This one got a little weird because the problems didn't come, but it's okay. On this one, you're going to match. We're just talking about in general, summarizing all things polynomials. So it says here, which statement best describes the end behavior of a polynomial function with an even degree and a positive leading coefficient? Okay, so we're even degree and a positive leading coefficient. That means Bob is waving his hands like he doesn't care, right? Whoop, whoop. So as x approaches both positive and negative infinity, y approaches negative infinity. That is negative, ghostwriter. As x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, nope. As x approaches both positive and negative infinity, y approaches positive infinity. And that is what we're doing. Okay, number 2, given a polynomial function with the zeros at x equals -2, which have a multiplicity of 1, and x equals 1, which has a multiplicity of 2, and x equals 3, which has a multiplicity of 1, what is the minimum possible degrees of the polynomial? Okay, your degrees come from adding up your multiplicities. Okay, so I have a multiplicity of 1, another multiplicity of 2, another one of 1. So that's going to give me 4. So my minimum possible degree of my polynomial would be a degree of 4. Okay. Next, we have a polynomial function graph shows the following behavior. X equals 2. The graph approaches from below, touches the x-axis, and continues upward. What can we conclude? It was weird. The polynomial graph shows the behavior at x equals 2. The graph approaches from below, touches. Oh, I see it now. Well, that's more of a cross than a touch, but okay. There we go. The graph approaches from below, touches the x-axis, and continues upward. So therefore, it has to have an odd multiplicity because essentially it describes crossing the x-axis. A polynomial function, which interval represents increasing behavior if the graph shows a 0 at x equals -1, where the graph crosses the x-axis, and another 0 at x equals 2, where the graph bounces off the x-axis. So this is a weird way of describing, but we have -1, where we're going to cross, and at +2, we're going to bounce. It didn't say where we bounce. It just says what are possibilities. So if I'm coming from the left, it's going to look like, okay, that's an option. Or if I'm coming down from -1 to 2, it could look like this. Okay, so these are my 2 possibilities that I'm working with. So between these options, what would be my increasing behavior? So I could be increasing here from -infinity up until I get to 0 at some point. Yeah, at 0. I could also, on this one, I'm increasing from 2 to infinity. Okay, 2 to infinity is an option. On this one, I would be increasing from 0 to 2, which is not an option. So it would have to be C using this graph. You would have to draw both graphs and analyze because it doesn't give you any other information to go off of. And it says, what is the degree of a polynomial where the function has 3 distinct real zeros, 1 with multiplicity of 2 and 2 with multiplicity of 1? Whose graph opens downward? Okay, so the graph opens downward. That lets you know that it has to be an even number. But paying attention to the zeros, it has 3 distinct real zeros. Okay, so you have root 1, and it has a multiplicity of 2. Then you'll have your root 2, and it has a multiplicity of 1. And then you have root 3, and it has a multiplicity of 3. So putting it all together, and you know that it has to be even, it would be a B. All right, so this is our fast and furious polynomial and rationals. This is the extra credit makeup assignment if you need it. So you would complete this and you can upload the picture to Canvas, or you can turn the paper in class. And that's it.